All right, I'm going to take a look at problem number 3 here, and we're going to be using our acceleration equations, and I want to get a little clear on how we should use those. So first of all, when we're doing problems like this, what we want to get clear on is the fact that we want to first begin by writing out the values of the variables that we are given in the problem. So a couple hints. When you start from rest, remember that the initial velocity is 0. And then we're going to get up to 80 meters per second to take off. So that means the final velocity is going to be this right here. We know the acceleration is 2 meters per second squared. We don't know the final position and we don't know the time. So when they don't give us an initial position, we're just going to assume that that is 0. So filling this in, that's supposed to be an arrow, by the way. 80 meters per second, and we have an acceleration of 2. We don't know the time. So first it says calculate the distance it needs to reach the speed. And if you notice, since we don't have the time, it's most useful for me to use the formula of the 3 up here that doesn't contain time in it in order to get the answer. So I am going to choose formula 3 and simply throw in the numbers. So that'll be 80 squared equals 0 squared plus 2 times x minus 0. So we're going to end up getting 6,400 equals 4x. And so for our final position, when we divide out by 4, we're going to get that x is in fact 1,600 meters. So the plane has to travel 1,600 meters to take off. So that's the first part. Now let's get the time it takes to reach the speed. We'll use the first formula because it's the easiest one to work with. That's v equals at plus v naught. So we have 80 equals a times t, starting at a speed of 0. And when we simplify this, we're going to actually get the t is 40 seconds. All right, so that's problem number 3. We'll take a look at problem number 4 in the next video.